Okay, we've got to express this here in the form r cos theta plus alpha. So from the formula booklet, okay, so A becomes theta, and B becomes alpha, and because it's plus, the plus option is the top option, so the top option there is minus, so sine theta, sine then alpha. Okay, so then we expand it to get r cos alpha cos theta minus r sine alpha sine theta. Okay, so then we equate both sides, so you can see then that we've got in front of the cos theta here is r cos alpha, which will equal to root 15, and in front of the sine theta here is r sine alpha, and in front of the sine theta there is just 1. Okay, so we've got equation 1, equation 2. So remember then we need to do 2 divided by 1. So r sine alpha divided by r cos alpha, which will be 1 divided by root 15. The r's will cancel, and then sine over cos becomes tan. So then to get alpha, you do tan to the minus 1 of 1 over root 15. And that comes out to be 14.5 degrees. Okay. So we've got alpha. To get r, remember then you need to square 1 and 2. Okay, and then add them. So that will be r squared cos squared alpha equals root 15 all squared, and r squared sine squared alpha equals to 1 squared. So if we add them, of course what happens when you add them is that you get just r squared on this side, yeah, because you're going to factorize cos squared plus sine squared, which is 1. If you add these here, then you're going to end up having root 15 all squared, which is just 15, plus 1 squared, which is just 1, so you get 16. So that means then r is going to be the square root of 16. We take the positive root, okay, because r has got to be greater than 0, and we get 4. So therefore, root 15 cos theta minus sine theta equals to 4 cos theta plus 14.5. Okay, so then in the second part it says hence find the solutions where it's equal to 3, where this is equal to 3. So in other words, we put 4 cos theta plus 14.5 equals to 3. So we find, of course, then the solution to this equal to 3/4. So I'm going to do cos to the minus 1 of 3/4. And I get 41.4. So remember then you've got to adjust your range, because we want the solutions between 0 and 360. We've got to adjust our range now, because the solution we've got here is for theta plus 14.5. So we add that on, and we add it on there. So our solutions need to be found in that range of the graph there. So I'm going to draw from 0 degrees, and I'll go to 450, so I'll include everything there. So with the cos graph, so we've got bin 3s, so 90, 180, 270, 360, 450, 1 and minus 1. So drawing the cos graph then, okay, and we've got the solutions then for 3/4, which is about there. So we've got the first solution there. So basically theta plus 14.5 will equal to 40 1.4, which is what we found. To get that solution there, if we think of it because of symmetry, it's going back from 360. Okay, so my graph's a little bit off here, but it's going back from 360, so 360 minus 41.4. And then there's another one here, which will actually be 360 plus 41.4. Okay, so we get theta plus 14.5 equals 41.4, 318.6 and 401.4, and then we've got to take that 14.5 over and take away . So we get theta equals to 26.9 304.1 and 386.9. Now I can dismiss that last one because it's outside the range. So two solutions here, 26.9 and 304.1.